Good afternoon, everyone. Thank you for joining. We're just going to be giving another 2 minutes here, just to let a few other folks join us. So just hold on and we'll be back in a couple minutes to get our webinar kicked off. All right, everyone, let's get started. My name is Lauren York and I work as our Senior Development Representative Manager here at Plotly. And today I have the pleasure of being accompanied by Nicolas Kruchten, who works as our VP of Product here at Plotly. Quick introduction to Nicolas. He is a huge contributor to our products and an excellent resource for us to pull some information from today as we talk about our dashboard engine. Nicolas actually has a huge contribution to the products that we've put together. He's actually our author of Plotly Express. He's very familiar with all of these different capabilities that he'll be going through. He's actually studied engineering at the University of Toronto and has previously worked in a few different verticals like telecommunications and of course healthcare analytics, which is a huge area that we're working in with different clients around the world. So I'll pass the microphone over to Nick and he will get into our meat of today's presentation.
Thanks so much, Lauren, and thanks for joining us, everyone. Before I get into the central part of my presentation, I just wanted to let everyone know that I'll be leaving about 10 minutes at the end for questions, so I'm going to finish at the top of the hour. But if you at any time during the presentation have any kind of question about what I'm saying or something about Plotly, please use the text box that you see right here. Our team is sort of standing by and we'll try to respond to you directly in real time. If they can't get to your question, then Lauren will ask me the questions at the end of the session. And if by chance there's some unanswered questions at the end, we will follow up with you by email. So please don't hesitate. I would be thrilled to answer any questions that folks have at the end of the talk. So let me get started. First, a little bit of an intro about Plotly for those of you who are joining us for the first time today. So Plotly is a software company. We were founded right here in Montreal in 2013 by alumni of Harvard, Stanford, and McGill. We have an open core business model. So that means we create a lot of open source software. And the Plotly graphing libraries, which my team works on, are downloaded over 16 million times a month, so quite heavily used. And the central library that powers our products is called Dash, and it's downloaded over 600,000 times a month. So Dash is the leading open source framework for building analytical apps in Python. And I'll be showing you a lot of examples of what we call analytical apps, but you can think of them as being sort of visually rich, data-heavy, interactive web applications. And Dash, like I said, is the leading framework for building these things in pure Python with sort of no JavaScript required. Our commercial product, which is called Dash Enterprise, builds on Dash and provides additional functionality for our enterprise customers, such as an app catalog to get started much more quickly with template apps, a development workspace to build applications directly in the hosted environment, a deployment server that provides scaling and access control for analytical apps, ways of doing styling, app snapshotting, and many more features. We've got some logos here on the right, and you can basically get a sense of our customer base is basically any vertical or any industry with a lot of data or models that they want to put a user interface on. Folks are using Dash and Dash Enterprise to build analytical apps, and that ranges from retail and supply chain to pharmaceuticals to finance, energy. Governments and sports teams are also using Dash Enterprise to sort of do the last mile of data science, which is to actually put the insights and data and models into the hands of users through a user interface. So that's a little bit about Plotly, Dash, and Dash Enterprise. And now I'd like to get into sort of the central part of my talk, which is delivering advanced analytics faster with a new capability which we have added to Dash Enterprise called Dashboard Engine. Which plays really nicely with all these other features that I've mentioned. And so I'm going to touch on some of them today, but mostly I'm here to talk about Dashboard Engine, which is something that my team and I have been working on for almost 2 years now. And we're finally ready to launch it and put it into the hands of customers and go with general availability. So I'm really excited to show it off to you today. Sorry about that. So let me start by sort of providing the motivation for Dashboard Engine. Why have we been working on this for so long? And The starting point is basically this application. So this is an application on our gallery. You can play with it right now at dash.gallery. And it's actually one of the oldest gallery apps that we have. It's a simple sort of dashboard style analytical app built in pure Python. And so I call this a dashboard style app because there's one sort of central data set that powers this entire app. And the app contains sort of multiple views on this same data set. So the data set is information about oil and gas production in the state of New York. And the views that you can see include a timeline for when the wells were built, a data card that shows you sort of the number of wells, how much gas, oil, and water have been produced. There are a number of widgets. So we've got this slider here, radio buttons, drop downs, and if I scroll down, I've got a map and some line charts for production. And the way that this app is interactive is that all of these widgets and data views are actually connected to each other. So you can see there's a little bit of the timeline has been selected here. If I select a wider range, everything will update. The slider updates, the number of wells updates, the map updates. I can hover over various points in the map here, and this line chart updates. I can choose to look at all wells, not just active ones. So this is a pretty typical dashboard style app. Now, this app was built using Dash Enterprise features such as Dash Design Kit. So there's basically no JavaScript, no HTML, and no CSS in this app. It's just pure Python. It's about 1,000 lines of Python code actually, which in the grand scheme of things is great because it's not that much. But most of over the years that we've been working with customers with Dash Enterprise, there's sort of two key questions that keep coming up over and over as our customers are sort of pushing the boundaries of what we can do. The first question is, how can Dash Enterprise help developers build apps like this faster with even less code? Why does it have to be 1,000 lines of code? Why can't it be much less, and why can't we go faster? And the second question that folks often ask us about is, what about people who aren't developers? So right now, if you want to make a modification to this app, if there's a user who's using it and would like this bar chart to be sort of colored by the well type or something like that, basically the way things work is they would sort of phone up or email the developer of this application and ask for a modification to be made. Now, obviously, with Dash Enterprise, we try and work hard to make sure that that cycle is as short as possible. But still, the question remains that our customers are asking us, how can Dash Enterprise empower non-developer end users to create and modify these views? And the way we've set out to answer both of those questions is with a single new feature, as I've said, to Dash Enterprise called the dashboard engine. So let me switch over into some code. This is going to be a bit of a deep dive webinar. I'll be showing you some code and showing you some applications to show you how the dashboard engine works. So here now is the source code for a very simple Dash application. It's about 20 lines of Python. If you're sort of this is your first webinar hearing about Dash, and if you've not seen a Dash application, you'll have to take it from me that this is quite short. And if you have built Dash applications before, you might be wondering sort of where's the rest of it, because it's maybe a little too short. So let me kind of go through this app because I'll be using it as a running example for a little while. At the very top, we start by importing various Python packages. So we'll import Dash, obviously. This is the open source Dash package. And then we're going to import two separate Dash Enterprise libraries. So the first one is the Dash Design Kit, which enables Dash app developers to not have to worry about CSS and HTML. All the styling is sort of taken care of for them within Dash Enterprise. And then, of course, we import the dashboard engine. So the dashboard engine is a proprietary Python library that's exclusive to the Dash Enterprise. We'll import it here. We'll import the theme. I'll talk about that in a minute. And then we start by connecting to some data. So here we're just importing pandas, the PyData standard way of processing tabular data. And we'll start by loading a data file from disk. It's in a Parquet file. We'll load it up, and it's a long form data frame. So it's got one column per variable and one row per observation. We create our Dash application, and then we create the dashboard engine object. And the way we connect it to our data frame is via this object here called the pandas connection provider. And I'll be talking a little bit more about connection providers in the future, but for now, this is essentially we're connecting this data frame straight to the canvas, or straight to the engine. We'll create a couple of blank objects, which I'll overwrite in a minute. And then this is where the sort of action happens. We're going to create a canvas object from the engine. We're going to put it into the layout of the application. and then we're just going to turn the application on. So if you've written a Dash app before, you may be wondering sort of where are the callbacks? Like, what does this app actually do? Well, let's take a look at what the app actually looks like when you run it. So unsurprisingly, it's not too visually complex given the small amount of code that we wrote, but looks can be a little bit deceiving. So we've got a nice little title bar here, as you saw, and this whole gray space here is what we call the canvas. And if what I was showing you a minute ago is sort of the developer experience of using the dashboard engine, let me now show you the user experience of working with the dashboard engine. It starts by clicking this pencil to put the canvas into edit mode, and then clicking the plus button to add an element to the canvas. So let me add a bar chart, and I've connected to the same data source as the oil and gas dashboard I was showing you a minute ago. So let's start by making that timeline of when the wells were completed. So I'll map the date the well was completed to the x-axis. It'll auto bin by year, and I'll put count on the y-axis. So far so good. I was able to add a chart essentially, without writing any code for it. I can resize this. I can drag and drop into position. So what about interaction and interactivity? Well, let me create a second element so we can see what that looks like. Let's make a drop down that will allow me to choose the well type, and will allow multiple selections. So now when I exit the edit mode of the canvas, if I make a selection in this drop down, say I choose dry well, cat wells, you see automatically the timeline here has updated. Now this is maybe not all that surprising. If you've got a drop down in a bar chart, playing with the drop down should change what the bar chart shows. But it turns out that actually this relationship, where a selection made in one element is reflected in all of the others, is multi-directional. And let me show you that by switching to a bar chart over here as well. So I'll go back and edit this, choose bar chart again. And instead of just sort of choosing the well types from a drop down, let's actually see how many we've got. So here now I have a bar chart of count by well type. It's maybe a few too many of them, so we'll limit ourselves to the top 10. And we'll color by well type. We don't really need the legend anymore because the x-axis is sort of serving as a legend right now. So you can see that this is a pretty powerful chart editor. And we'll go and add the same colors over here, just to kind of keep track of things, keep things colorful. All right, so now, if I make a selection in the timeline, say I just choose wells that were created before 1950 or so, you can see that the bar chart updates. And if I choose, just oil development wells, you can see that the timeline chart updates as well. I can double click to reset. So this is what we call cross-filtering. Selections in one element are automatically reflected in every other element. Speaking of elements, what else can I create? Well, if I slow down a little bit and actually walk through this element type dropdown, we can see that we've got a number of visual representations of data like bar charts, scatter plots, line charts. I'm going to make a bubble map in a second. We've got pivot tables and data tables, big number indicators, and a number of controls like a drop-down menu, a date range picker, and so on. Let me start by making a map here, because these are actual wells that exist in the real world, and so they have a location. And we'll keep using the same color. All right, so I've got a map now. I can zoom in on it, sort of typical Google Maps style interactions. And this map also supports cross-filtering, so I can select, that's interesting, some oil and gas wells, in downtown New York. Okay, geothermal, sounds good. And I can also, look at the ones that were created most recently, and everything sort of continues to cross-filter. So maps come built in. But now let me show you my sort of very favorite data analysis tool, which is called a pivot table in action with this data set. So a pivot table is a special kind of table where you can map data to both the rows and the columns. So I'll start by making a count pivot table, and I've got 21,000 wells in this data set. And down the rows, I will add the well types. And so right away, this is starting to break out by well type. So this is the count. And across the top, I will put the well status. All right, so now each cell contains sort of the number of wells that are at the intersection of a status and a type. This is maybe a little hard to read, so let's see if we can clean it up, make it a bit bigger, add some accent colors. You can see this is probably the biggest number here. Probably don't need the title. And just to keep things clear, let's look at the top 5 values for each of the type and status. All right. So this now is an interactive pivot table. It's interactive because you can actually make selections directly into the pivot table here. So if I just want to look at active wells, no problem. The whole dashboard automatically filters. I can just choose oil development wells. And if I just want to look at plugged and abandoned dry wildcat wells, I can double click here to make a selection. And then of course, the pivot table itself is also subject to cross-filtering. So everything is sort of cross-linked. So before I get too lost in exploring this data set with these powerful tools that I have, let me kind of bring myself back to order and sort of connect back to why I first started talking about this. So the reason I was showing you this app is to show you how the dashboard engine can make it faster for a developer to make an app. So I started by showing you my 20 lines of Python code, and then I started making a dashboard. So the way to connect back to the code is you open up the pencil again, and you use this middle button here, which is the inspector. So when I click on the inspector, this pop-up appears, which shows me the actual Python configuration code for the canvas. So I've got a list of elements, which is essentially these four items, and then an arrangement which describes sort of where they're positioned in space. And what I can do is I can actually copy this code, go back to the source code of my app, and where here I have these 2 empty objects, I can actually paste this right in and save. And if I switch back to Chrome, I'll take my hands off the mouse, it'll refresh by itself in a second. And you see now that the state has been changed. If I had any selections there, they would have been saved as well. And if this app was connected to a live data source, as I'll show you in a little while, rather than a static one, then this app would be sort of either updating on a schedule or as the user interacts with it. So this is a way in which a Dash app developer can start with a very small amount of code, switch into kind of point and click mode, get the code back out and bake it into the app. Now the pencil is still here. A Dash app developer can hide the pencil from a user if they want by just setting the editable field to false. And you've also got this edit theme button. Now the edit theme button doesn't actually come from Dashboard Engine, it comes from the Dash Design Kit, but it's also extremely powerful. And what it lets you do, should probably switch out of full screen mode to do that. Excuse me. What the Dash Design Kit theme editor lets you do is it lets you control the styling of this entire application with just one click if you want. So I can switch into dark mode, say, by just clicking over here, and you can see that everything about my app here has been restyled, from the font to the colors. There's now a little border around these cards, and a developer can basically do the same thing with the theme editor as I was doing with the inspector, which is to look at the save button, load the Python code here, copy it, and then paste it straight into the application to style not only what the visualizations are, but also their colors and so on. So this is all well and good for a developer who has access to the source code of an application, but it doesn't really make life much easier for an end user, because when an end user is done sort of editing a dashboard with this pencil tool, what are they going to do with this source code other than potentially be confused by it? Well, the good news is that it's actually very easy to provide end users with a save button. So let me show you how that's done. So if this was my simple sort of 20-line starter app, let me switch over into a slightly more advanced version of it. So if I scroll down to the bottom here, you can see that this is 60 lines instead of 20. And what this app does, I'm loading the Dash snapshot engine, which is another proprietary library of Dash Enterprise, which lets me save the state of an application to a database. And I'll load some of the dependency objects from Dash, like input, output, and state. And I'll create my snapshot object. And instead of just putting the canvas straight into the layout, I will make it such that the app layout is a function. And this means that every time the application is loaded, this function is called rather than a static layout being generated. And what this function does is basically right here in this little try except block, is it tries to load the latest snapshot from the database, which is just one line here. And if there's no snapshot, it'll just give me an empty set of elements and arrangement. And I've added a save button to my layout here. And then finally, callbacks make an appearance again. This is a very simple callback, which basically captures the state of the dashboard via the state object here, and uses the save button as an input. And when a user clicks on the save button, I'm going to save the snapshot. So if this all seems a little abstract, let me actually show you what it's like to run this thing. It's the same app as I was showing you before, except there's a save button. And when I'm in the editor, there's no more inspector. I've hidden it because an end user doesn't really need to see the configuration code. So I'm not going to rebuild the entire thing I just did, but I will just create that little timeline bar chart just to show you how saving works. So here we go. And now, as a user, say I've laid out a view that I like, maybe a really nice long timeline, I can hit save. It says, save one time, click to save again. But the good news is that then I can reload and the app stays exactly the way it was. I can go back and edit it again, say add the colors. Great, hit save. And again, the app is saved. And now whenever I visit it as a user, I've got the view that I wanted. Now, this is maybe a little simplistic, maybe not something that you directly sort of deploy to production, because it's sort of a little bit weird to have any user be able to edit the view that any other user sees. But in some small team context, this might make sense. If you would like to deploy a similar application or to give this sort of capability to users in a context where there are perhaps many users, you could configure the callback to only show the save button to a certain set of users who's allowed to do so. So to create a set of power users that are able to configure the application, and then everyone else sees the application that was configured for them. Or you could build a slightly more complex application like this one, which allows any users to create any number of saved views. So the three applications that I've shown you, the one where sort of nothing is configured, the one where there's a save button, and this one, are all actually part of the Dash Enterprise app catalog. So these 20 lines of code, 60 lines of code, and this new app that I'm showing you here, which is about 200 lines of code, within Dash Enterprise, you basically just one click, you can deploy an application based on these, and then in the workspace, sort of fill in the blanks and connect it to your own data. So this application here, like I said, is about 200 lines of Python code, and it has a new dashboard button. So any user who has access to this can have access to this sort of blank canvas. But users can also see dashboards that have been created in the past. So I created and saved a dashboard here to show you, which is essentially a replica of the app that was in the gallery. So this is the application that I first started showing you, 1,000 lines of Python code, maybe took a few days to write. And this is essentially the same application connected to the same data set, and I built this in about 5 minutes. In fact, there's a recording of me doing this in 4.5 minutes, just by pointing and clicking my way through. And it works great. You've got full cross-filtering here. We've got the map. We've got the widgets to select the well types. You can select the well status. There's line charts for the production of gas, oil, and water. There's these big data cards, and it's fully editable by a user, not necessarily a developer. So if a user, say, wants to swap the position of these two cards or create new ones or whatever, no problem. Click edit, swap the cards around, and hit save. Now there's also a save a copy button in this particular app, so that users are not necessarily overwriting each other's work, but sort of forking and building on each other's work. And there's a delete button. So this application shows the sort of full life cycle of what's possible to do with any given dashboard. Since I was going to show you this app, I sort of took the opportunity to create a couple others, a couple other dashboards. So here's one that shows kind of a neat feature of both our data tables and our sort of cross-filtering engine. So this might not be immediately obvious, but you can actually use the dashboard engine to do quite detailed drill down. So in this app, in this dashboard, sorry, which is quite simple, I've got a pivot table here on the left-hand side and a data table on the right-hand side. So the difference between a pivot table and a data table is that a pivot table always shows you aggregated data. In this case, I'm showing you the number of wells, about 15,000 here. And in a data table, I'm actually showing you essentially raw data. So if I were to actually scroll through this data table, I would be able to scroll through all 15,000 of these wells. But if I'm interested in, the name of the one active dry hole well, which I don't know, maybe is a data entry error, I can double click here and I can actually drill down to the individual well here. So to really make quite precise selections. And in fact, since the canvas is just another Dash component, it's possible to capture this selection as a property of the canvas to power other callbacks in the application. And so you could use the dashboard canvas to build essentially a query tool for users to make very precise selections, drill down into something that they're interested in, and then show other information or feed their selection into downstream processes like a machine learning model or a statistical model or a workflow or something like that. So this is something that's kind of neat that you can do. You can do drill down via cross filtering between tables. So since I'm looking at all these numbers, I should probably talk a little bit about data volumes. So I've got about 15,000 wells in this data set. And the whole data set is about 200,000 rows because I've got information about wells and also their production. So in the real world, this is a fair amount of data. It's information about every well that was built in the last century or so and production data for every year. But in the grand scheme of things, it's not that much data, right? 200,000 rows. This is about the limit of what the Pandas connection provider can handle. Now, anytime in some of these more complicated dashboards, anytime I'm clicking on something, you can imagine all the data processing that's happening in the background, right? Anytime I do a selection here, we're using Pandas to compute sort of these counts, all of these line charts, all of these maps, and that's fine. Pandas is quite powerful, but Pandas can be a little bit memory hungry and will tend to sort of iterate over the data over and over and over as it's doing computation. So this data set is about the max that I would recommend for Pandas. But in order to unlock larger data sets, we had to look towards a different data frame technology. So we worked very closely with the folks who make VEX, which is spelled V-A-E-X, to scale the the data volumes that the dashboard engine can handle up into the tens or hundreds of millions of rows. So this particular demo is showing you data from the Open Cell ID project, which is essentially a data set of cellular towers across the world. It has 41 million rows of data, and it's powered by the VEX data frame. So VEX is has a Pandas-like API, but it's a totally ground-up implementation in C++ of a data frame that's sort of almost obsessively careful about when data is copied and when the data frame is traversed. And the second feature that makes VEX such a great fit for Dash is the way it handles memory. So when you have multiple workers in a Dash application, which is the default with Dash Enterprise, with Pandas, each worker actually holds a copy of the entire data frame in memory. So if your data frame is 1 gigabyte and you have 10 workers, you're actually occupying 10 gigabytes of memory. This is not the case with VEX. VEX not only can handle data frames which are bigger than memory by sort of spilling to disk, but it will share the memory among workers. So if I have 10 workers and 1 gig of data, I'm only occupying 1 gig of resident memory, which means that for any given machine, you can actually scale to much larger data sets while maintaining multiple workers and not having that sort of parallelization to memory trade-off. So technical details aside, let me actually kind of show you this application. I've got 1 row per cell tower and information about sort of where they are to power this nice map. I also know in this data set the radio technology that was used that this particular cell tower uses, and then when it was built, and the name of the operator. So already just looking at the map, you can see some interesting patterns. So there's more orange here in the US and in Japan, and maybe more green and blue over here in Europe. So that's kind of interesting. Let's take a look perhaps at making a selection over towers that were built a little while ago. We'll give this a second to update. And you can see that this geographic change holds even in the past. You've actually got some red here in the United States, which is the CDMA technology. So if I actually reset this and select just CDMA towers, we'll see that actually this geographic split is pretty interesting. CDMA is sort of an older technology that was only really massively deployed in North America, perhaps a little bit in East Asia. So you can kind of explore some neat patterns as you interact with the bar charts. But we can also look at some geospatial patterns. So if I zoom in here to Europe, we can almost see the country boundaries appearing. You've got, France right here in green, Germany is looking quite blue, the Czech Republic is looking quite orange. So you can see that the different national operators have made different technology choices. You can see that in Germany, there's a lot more, say, blue in the rural areas, whereas in the Czech Republic, there's more orange. So, we can maybe look to see, is there any orange in Germany? Just select the LTE bar here. and see that in fact, yes, there is in fact a whole lot of orange. And since I've got Europe here in view, you can see that the dominant operators are France Telecom, Vivendi, and other European operators. And in fact, we can look at just France Telecom, and unsurprisingly, the view will show you that it's mostly France, but also parts of Belgium. So this is how you can use the dashboard engine with really large data sets up into the 40 million range. And you might be asking yourself, well, what kind of hardware is this running on? Is this running on some sort of GPU or sort of exotic cluster or something like that? The answer is no. It's just running right here on my laptop. It's not even, I would say, particularly taxing my laptop. And that's essentially the power of the careful engineering of the VEX data frame. So the reason I like showing this dashboard engine app is because, much like the oil and gas app I was showing you a little while ago, this is also a remake of an app that's on our gallery. So here is the version of this app that's on our gallery. It's basically the same thing. We've got a map, we've got a counter of towers, we've got some bar charts here, and it does roughly the same thing. Now this particular application we built as a showcase of how Dash can connect to Dask, which is a cluster backend, and it was built by one of our most senior Python engineers, and it took him about a week or a week and a half to build. And so the reason I like kind of contrasting these two is that this particular application took me about 15 minutes to build in Dashboard Engine just by using the pencil. All of these are sort of fully editable. I can sort of click and reconfigure these. So loading the same data set from the same Parquet file, I was able to build this in 15 minutes compared to about a week and a half. And that's literally building an application like this 100 times faster. And this is a sort of soundbite that's been borne out by conversations with early adopter users of Dashboard Engine, both folks like myself and on my team, as well as early access customers who've had Dashboard Engine in their hands for a few months, is that they're uniformly saying that you can build Dash applications 10 to 100 times faster using Dashboard Engine, because you don't have to sort of hand code all these interactions, and you're able to actually iterate much faster. So you can actually play with making a bar chart here, making a table here. Oh no, maybe this should be a bar chart. Maybe this should be a table. If you're actually hand coding all of these things, the iteration process is very slow, and you maybe are, resistant to change because, well, we already got the bar chart working and stuff. Whereas if you're able to do this in sort of a point and click way, you're able to iterate much faster. And so this is borne out not just in the number of lines of code that you have to type, but in the actual lived experience of folks who are building applications with the Dashboard Engine, which we're really, really excited about. So I've shown you, a couple different remakes of gallery examples that we've got, but both of them use essentially static data, right? So here I've got one data set. It's big, sure, but it's sitting on the disk of my laptop here. I can almost hear the thoughts of some of the people on this webinar saying, yeah, but here we work with real-time data or data that updates frequently. So how do we connect the Dashboard Engine to enterprise data sources that aren't static on disk? And so the answer to that, I'm gonna have to go show you a bit more code. So if we look at the second application that I showed you here, I told you that the way that the Dashboard Engine connects to data is via a connection provider. And here I'm using the Pandas connection provider. For the OpenCellID demo, if I were to show you the source, you would see it's using the VEX connection provider. To connect to a sort of arbitrary type of data set, you have to write your own connection provider, which thankfully is actually very easy. So here, I'll show you a demo of a custom connection provider that I've written for this webinar. So a connection provider is simply a Python class that exposes a get connection method. And the contract between the engine and the connection provider is that the engine will call the get connection method, one, anytime the user interacts with the dashboard, or two, anytime the connection parameters change. I'll talk about the connection parameters in a second. And what happens inside this get connection method is essentially up to you as a developer. So in this particular case, I've called this the random walk connection provider. And every time this connection is called, this connection provider is invoked, it will return data from a sort of simulated random walk. And it does so as a function of a random seed. So I built this little application where I'm connecting the random walk connection provider to the engine. I've built my canvas, and then I've put in two special components into my layout. One is an interval, which fires every 1500 milliseconds. That's 1.5 seconds. And the other one is basically a numerical input, which lets me specify the random seed. And then at the bottom, I've got another simple callback, which basically says whenever the interval fires or whenever the random seed changes, set these values in the connection parameters. So actually running this application gives this output. And you can see that every second and a half or so, I've got a new data point that's appearing without me particularly interacting with it. And so this is a pretty good example of sort of how the dashboard engine would work with live data. And I've got my little input here where I can tweak the random seed. And so I can actually look at different random walks that start with different random seeds. And I can go back and interact with that. And so this is essentially where you're seeing that contract in action, which is anytime I interact with a widget, the get connection method fires. And anytime an interval fires, the connection parameters change, the interval fires. So this might seem like a bit of an abstract example, and it is, but the reason I chose it is because it really exemplifies the kinds of things that you can do with Dashboard Engine. So you can write a connection provider that connects to any kind of data source that Python can connect to. And that literally really is everything. So if you have data in a Databricks cluster, if you have data in a SQL database, if you have data behind an internal REST API or an external REST API, that data can be queried right here in the middle of this get connection method. There's no restriction. This is pure Python, just like the rest of Dash. You can think of this as being essentially a kind of callback within the dashboard engine that lets you really control quite carefully what data is fed into the dashboard engine. Now there's one more parameter to this get connection method, which I haven't mentioned yet, which is the user data parameter. This object is provided anytime the get connection method is called, and it is the output of the Dash Enterprise Auth package. Now Dash Enterprise Auth is the connection between a Dash application deployed on Dash Enterprise and the authentication system within Dash Enterprise. So anytime the get connection method is called, it knows who the current user is. That means that if credentials need to be passed to an upstream data source to identify the querying user, that can be done. Or if this data set needs to be filtered to provide row level security or sort of like row by row access, this user data object can be used to enforce that policy within this get connection method. So what's really neat about this is that it really kind of shifts the workflow that a Dash app developer goes through when building a dashboard. Whereas in the past, a Dash app developer would be responsible both for the data and the UI and might actually be spending a lot of their time, this is what we're hearing from our customers, spending a lot of their time in the layout, configuring the graphs. Now, most folks who are using the dashboard engine are mostly writing connection providers and curating the data and working with the data engineers upstream, doing modeling, and working closely with users who are building the visualization with their mouse. And this is really exciting for us because it's sort of allowing every member of a data intensive team to focus on their strengths. So I don't want to leave you with just this random walk data here at the end of this webinar. So I wanted to show you one last little app. And this one is a little bit unique. So it's not a particularly large data set, but there are sort of 3 reasons why I'm excited to show you this app. So first of all, the data set itself. It's basically a list of all the Dash for STEM, so Dash for science, technology, engineering, and math apps that we were able to find on social media. So there's actually a salesperson on our team who's been carefully building this data set. Anytime he comes across an application that shows that people are using Dash for science or technology, this sort of gets a row in this data frame. So that's the first reason I'm just excited about this data set, because it shows that people are building apps to do STEM work. The second reason I'm excited about this Dash app is actually because it was built by a salesperson. So, when I was showing you the Open Cell ID dashboard, I was saying that, the original one was built by one of our most senior Python engineers. And that's true. What I like about this app is it was built by someone whose job doesn't even include really any Python, right? A salesperson, even at Plotly, doesn't tend to spend most of their time building dashboards. But Dave told me, the guy who built this app, told me that he would not really have probably started building this app had he had to build it from scratch, even with all the power of Dash Enterprise and the app catalog to sort of start from a starter kit, because it's just too much code to write. But given that he essentially had a CSV and wrote a little bit of pandas to sort of condition the columns, he was able to, the difficulty level was lowered enough that he was able to undertake this project to kind of build an interface to explore a data set that he cares about. And so this data set, for each app, we sort of tried to figure out when it was built and where it was built and what kind of app is it. Now, some of them are apps, some of them are blog posts, sometimes it's a video. And then there's the domain. So there's, computational biology, epidemiology, microscopy. We've got a nice little table here with the title or the name of the app, the organization that's produced it, the country. We can have some cute emojis here. So the third reason that I'm excited to show you this app is because it actually shows something that you can do with a custom connection provider. So when Dave was building this app, he was telling me that he would really like to have kind of a full text cross-field search, which is not something that's actually built into the dashboard engine right now. But because of the sort of custom connection provider architecture, that didn't actually have to limit his creativity or what he wanted to do. He was able to add this text field here as one of the connection parameters to a really simple connection provider that all it does is it applies a text search to every column. And so if I want to search for just sort of, Canada here, you get sort of full text search on the country. If I want to look for genomics, gotta type it correctly here, genomics, it's doing full text search on the category, and it's finding some things about plant science and some things about computational biology. So this is an example of using the sort of like open, accessible nature of the dashboard engine, even though it's not open source. It has an open, extensible API to be able to build a connection provider that meets the needs of the application, in this case, to add full text search. And so this search is happening before the data is being presented to the dashboard engine canvas. And of course, this is fully editable. So Dave built this app using this pencil. And if there's some part of it that I don't like, or I want to change things around, I've got access to this pencil. So this is a really, really neat application. Showing also just like a neat data set. You can see sort of Dash usage really taking off since 2017 when we first released it. So that's kind of the last demo that I wanted to leave folks with. And just to kind of close out my presentation, I wanted to say that Dashboard Engine is part of Dash Enterprise 4. It will be generally available in the next release of Dash Enterprise 4, which will drop in early January of next year. So you can have this, you can have access to this today under early access or as part of general availability as early as 3 or 4 weeks from now. So please get in touch if that's something that's of interest to you. And I've left just about 15 minutes for questions. So if you have any questions now, please type them into the box. Otherwise, feel free to email us your questions later. I'll hand the mic back to Lauren now so she can kind of pull together from the list of questions that have been asked. Yeah, thank you very much.
Awesome. Thank you so much, Nick. That was incredibly informative. Honestly, I was personally really excited to participate today because when I'm having a lot of these discovery calls with different clients, they're typically asking for more information on Dashboard Engine. And I really love the last visualization you showed. And I can also attest, being in sales, I can appreciate how important it is to have a platform that can be used by multiple personas. So thanks for showing that. I also really enjoyed the way that you can customize the visualizations. And so I find when I'm watching you do this demo, it's actually the perfect segue because we are seeing that there are a few questions coming in where some folks are wondering how constrained or customizable the visualizations or behavior of Dashboard Engine apps can be. Is it something that's like an all or nothing, or can this be integrated into the existing Dash apps?
Yeah, absolutely. That's a great question. This is a very natural question for folks to ask, especially when confronted with a framework that seems to kind of take care of a lot of the details and do a lot of the magic. And I think this is something that folks, part of the reason why folks really like Dash as a solution for building analytical applications is it gives them a ton of power. And so while we were building the dashboard engine, we absolutely did not want to take any of that power away from anyone. And so as I hope I've shown you a little bit through some of these applications, Dashboard Engine isn't a totally new way of writing dash applications. It's basically one new component type. And so you can see here, although I'm creating an engine object, I'm mostly getting a canvas object from the engine, and I'm putting this canvas right here in the layout. Now, although the first app that I showed didn't have any callbacks, just because it was a really simple demo to show how the canvas worked, I did show some apps here that do have callbacks, and this shows essentially that the full power of Dash is still available to you while you're using the dashboard engine. And it's not so much about getting the power of Dash in the dashboard engine as the dashboard engine adding to the existing power of Dash. So another thing I'll show here is within this sort of self-serve dashboard application, when this toolbar here is not actually powered by Dashboard Engine. It's regular Dash. This back to list button, this table, this new dashboard button. When I'm actually editing something, the controls over these drop downs, who has access to this dashboard, these save buttons, this is all regular Dash, and developers can sort of fully control all of this. With the Dash Design Kit, you can control the colors as well and the layout. So if you want to have drop shadows or a dark mode or your own corporate theme, you can apply it to that as well. The final thing I'll say here is that the list of elements that you have when you are building a dashboard today is this list that I've shown you, and I've shown you a number of them. But in the next version of the dashboard engine, we will actually have an SDK for developers to be able to develop their own elements. So if you are making charts, or if you need to make applications that have types of charts that aren't one of the ones that we've listed here, or if your users are really used to seeing a particular kind of chart, maybe one with a dual axis or a particular kind of trend line or something like that, this is definitely a functionality which will be coming to the dashboard engine. You'll be able to create your own custom element types and put them into the dashboard engine. The sort of credo of the dashboard engine, it's just regular Dash under the hood. All of these elements are built with Dash components, and we plan on providing the full power of Dash to all dashboard engine users.
Awesome. Okay, thanks for such an elaborate answer. We're also seeing some questions here around specific data sources like SQL databases or internal APIs, and also some specific questions around visualizing multiple data sets at the same time. Is that something that you could speak to as well?
Yeah, of course. So obviously, the vast majority of use cases that our customers work with are data sets that change over time and maybe not amenable to just being static data frames. So the custom connection provider mechanism is basically our answer to that. And there's no restriction to the kinds of data sources that you can connect to with the custom connection provider. You can connect to anything that Python can connect to. If you have data in a particular vendor system, I'll bet you that if you Google vendor name Python, that vendor provides a first-class Python API for connecting to it, and you can write that code right here in a custom connection provider. And although it's not something I touched on, it's worth mentioning that if you have multiple data sets or multiple different types of data that you want to visualize, one thing that you could do with that is build a custom connection provider that essentially blends that data on the fly. So if you have data from two separate upstream APIs that you want to visualize together, inside a custom connection provider, you can actually make two queries and do a join or a blend to sort of correlate this data before it gets into the canvas. So that's one way that you can handle multiple data sets. Another way, which I also didn't mention, is that you can have multiple canvases on the page. So all of the demos that I showed, have just the one pencil here and one set of cross-linked visualizations. But if your data set, isn't amenable to sort of blending and correlating, you can actually have multiple canvases on the page, multiple pencils. There's really no restriction here. A dashboard engine canvas is literally just a component like any other, just like this dropdown is a component, so you can have as many of them as you like. The only constraint is that the cross-filtering is only sort of within a canvas. So if I had another canvas below this one, which had information about the weather or something like that, you wouldn't be able to sort of filter the weather canvas down and have that selection reflected over here in this canvas. But other than that, there's no limitations on multiple data sets.
Perfect. All right, thank you for clarifying that. I'm also seeing a few questions that have come up in the chat today, and definitely something I've seen in conversations as well. Folks are asking about whether Dashboard Engine lets you control who can actually create and view the dashboards, as well as some questions around row-level security. Just wondering if you could provide a little bit more detail on who can see what data within these different dashboards and visualizations.
Yeah, absolutely. So this is definitely a concern that's top of mind, especially with our enterprise customers. And the answer here is going to be a little bit layered. So Dash Enterprise, when you deploy an application, you can choose who is allowed to see this application. So Dash Enterprise connects to enterprise single sign-on systems for authentication, which is identifying who the user is, making sure that this is an actual sort of legit user. And once Dash Enterprise has authenticated the user, there is application level authorization. So is this user authorized to connect to this application at all? And if not, you get a standard sort of permission denied screen. Now, once Dash Enterprise allows the user to connect to the application, anything that user does within the application is up to the actual application developer. And this is where the architecture of the Canvas and Dashboard Engine really sort of fits hand in glove with Dash, because there's no it's actually not the Dashboard Engine that's deciding who can access what. It's the actual application code. So there's sort of two ways that this comes into play. One is, as I've mentioned before, the fact that these buttons up here and sort of this drop down is just regular application code. It's not sort of a box that Dashboard Engine provides that your application has to fit into. So if your needs, say that there's 4 named individuals who have the save button, but everyone else can save a copy and only administrators can delete, then that's application logic that you can implement. If the identities of these users, live in some upstream system or is linked to a sort of an LDAP group or something like that, this information can come into Dash Enterprise to your application via an API call, and the right controls and the right permissions can be applied. So that's in terms of what the user is actually doing. The second, so the deepest level, I would say, of security and access control is what's often called row level security. So the sort of canonical case that I often bring up is something like an HR dashboard. So if you have a dashboard that shows salary information or something like that, certainly you would want to make sure that only people in HR have access to the dashboard, and Dash Enterprise will handle that for you. You sort of say this application is only accessible to folks in HR. But then within the set of people who have access to the application, you want to make sure that people on the East Coast only have access to East Coast information, people on the West Coast only have access to West Coast information, and that's row level security. Sort of once the data is in, who can access what is again something that would be encoded within the custom connection provider. So this user data object, which comes in from Dash Enterprise Auth, contains everything you need to be able to say, this user is Lauren. Lauren is an administrator and she has access to everything. But Nick, Nick works in Montreal and only has access to Montreal salaries. And then here, the custom connection provider can actually apply those rules in whatever sort of business logic specific way makes sense for the actual data source. So we're basically trying to provide a set of tools for Dash app developers to be able to implement whatever business logic they need to, rather than us trying to sort of figure out the set of business logic and forcing app developers to sort of fit into that box.
Fantastic. Okay, thank you. And this will be the last question for this afternoon, but I think it's a great one to end on. There was someone who asked about Tableau and Power BI. I'm curious if you could just take a few minutes and talk a little bit about how Dashboard Engine compares in this space.
Yeah, absolutely. So that's definitely a kind of a natural comparison to make. One of the things that we say about Dash and Dash Enterprise is that Dash apps can go where Tableau and Power BI can't. And largely that's based on the fact that because Dash applications are written in Python, there's sort of no constraint. This has been maybe a running theme of what I said so far. There's no constraint on what these applications can do other than that they have to be implementable in Python. So Dash applications can run machine learning models, query API, custom APIs that were built in-house that maybe no other vendor has ever heard of, but you know how to query. And that's kind of the power of what Dash can do, which I would say standard BI tools can't do. And so what we're trying to do, what we're doing with the dashboard engine is we want to give some of that user experience, some of that drag and drop, point and click user experience to Dash developers to be able to either use themselves to build these apps faster, because one of the nice things about Tableau and Power BI is that kind of point and click, drag and drop user experience. So we want to bring the best of that user experience into Dash to solve to sort of answer both of those questions that I brought up in the very beginning, which is one, how can Dash Enterprise help Dash developers build apps faster? And so one way that we answer that is with this sort of drag and drop canvas, and then we generate the code to bake into the application. And then the second piece was how can non-developers be empowered by Dash Enterprise? And so historically, this has been kind of one of the big sort of bright lines in the world, is that Dash and Dash Enterprise are a low-code platform for building analytical apps. So you don't have to know everything about every kind of web technology. It's not a high-code platform, but it's also historically not been a no-code platform. In order to get anything done, you always had to write a little bit of code, or a Dash app developer has had to have built a user interface to enable a user to do certain things. And so what we're doing with Dashboard Engine is we're starting to blur that line a little bit and provide more no-code type experiences to users of Dash applications, but still mediated by the code that a Dash app author has put together. And we're really kind of chasing the best of all worlds here, where users, once the data has been curated, once the models have been written, once the Python code is kind of gluing everything together, users do get this pencil and the ability to kind of edit this bar chart and do what they need to do without needing to write any code. But it's still a full-fledged Dash application that's able to run TensorFlow models, connect to S3, do whatever it is that folks are using Dash for that they're not able to do with Tableau or Power BI or other comparable tools. And in fact, something that came in last week as a sort of customer testimonial is one of our customers told us that that their users actually are preferring to build things with Dashboard Engine over Power BI because the interface is simpler, and it's more straightforward, it's more streamlined. So that's also kind of an interesting data point. But definitely there's some overlap, and we're starting to kind of blur the lines between low code and no code in what I hope are empowering ways.
Awesome. Okay, great answer. And thank you so much again to you, Nick, for sharing all this insight with us today. And thank you to all the attendees for joining us. Thank you for your great questions. And be sure to look out for our recording after the webinar, just via email, and we'll provide some additional resources as well. Of course, always feel free to reach out to us at info@plotly.com if you have additional questions. I hope everyone has a great rest of their week, and have a great afternoon for those in North America.
Thank you very much. Cheers.